artificial intelligence at Utrecht University with Anja Volk, where I did research on automatic chord recognition. And after my PhD, I started working at RTL. So this is the largest commercial broadcaster in the Netherlands, and they're all over Europe actually, and they're part of Bertelsmann Group, which also owns BMG, the record label. So that's a really large media company. And when I started working there, I met Karen van Dijk, who works at the VPRO, who had this idea of organizing an AI song contest. And it was she had really big ideas of organizing it with virtual characters who would be singing, and like everything would be AI generated. But we had a lot of talks of how we could actually make this manageable. It took place last year. It was really exciting. We had 13 teams, and what I wanted to show or talk about in this presentation is basically a couple of lessons that we learned from this AI song contest by taking sort of like an overview of all the submissions and the analysis of it. So let me share my screen. Oh, wait. Yeah. All right. So looks good. Okay, great. Okay, so this so I'm going to tell you something about the AI song contest of last year and all the submissions that we got. So a quick recap. So it was a contest that was organized by the VPRO. This is the one of the public broadcasters in the Netherlands, together with 3FM, which is the local or the national pop music channel, public pop music radio channel. It was inspired by Eurovision contest, so it was kind of modeled like the Eurovision Song Contest in terms of which teams could join from which countries and how they were judged. They were judged in a similar way. I'll come back to that. So the task was to create a 3-minute song with the help of artificial intelligence, and this was kind of we set this up quite broadly, or we didn't restrict the use of AI that much. We just wanted to be how can the AI be used in the most creative way, or that it helps with the creativity of the songwriters. So there was no hard line of you should use this amount of artificial intelligence or everything should be created with artificial intelligence. It was more about how, in what kind of interesting way can you use artificial intelligence in your creative process. So 13 teams signed up from all over Europe and Australia. This is because of this weird thing where Eurovision also allows countries from outside of Europe. So we modeled it after that. And so these 13 teams, they consisted of musicians, artists, scientists, like data scientists, but also researchers at universities, and also developers from companies. So there were some teams that were the software development team from a company, for example, who also did data science at the company. They joined to see if they could make music with the tools and the knowledge that they had from working there. We had a jury of AI and music experts. So that was Anna Huang from Google. She's a researcher at Magenta. We had Ed Newton Rex from he's at the TikTok now. He's a head of the AI lab at TikTok, at ByteDance, and myself. So we looked at the process documents that the teams submitted. So in addition to the music, so this 3-minute audio that the team submitted, they also submitted a document. The audience voted for on a couple of categories for the audio file. So they were mostly judging on how much they liked the song the teams created, and we as a jury we looked more at how was AI used in the process, and where was it used, and what was the team dynamic? Was there a lot of interaction between musicians and the AI researchers, and how did this work? So we were not as much concerned with the aesthetics of the song eventually. So we got 12,000 audience votes from some 70 countries. And eventually the voting was also supervised by the EBU, who is so that's the European Broadcasting Union, who is also an organizer of the actual Eurovision contest. So the general idea, as I said, is that the contest wasn't set out as a kind of like a measurement of how much AI can you use to create music, or can we replace musicians, but more from the idea of how can AI help in a practical sense with songwriting, and also how can we get these tools and these models and all this knowledge from that's at deep learning researchers or data scientists. How can we get those ideas and models in the hands of musicians? And one of the teams, I think this is a nice comparison, is that one of the teams said that so the piano brought along an explosion in human creativity, and one of the teams said that they also believe that AI is kind of like a next piano, and they wanted to be part of making this happen. So in the end, we also had an actual live show with a presentation, and also modeled after the actual Eurovision contest, where the winners were announced, and we had some interviews with the teams. The presenter was wearing a shirt that was also created with AI. It was kind of like a mix was created, like with a gun. They tried to generate a new, or kind of like the average sort of like a outfit that the presenters of the Eurovision contest actually wore. It's a funny side note. So this is actually the actual content of my presentation. What I want to talk about is that we, as an AI jury, we analyzed all these process documents that came in, and that's what we judged the teams on. And we wrote an ISMIR paper, where we kind of took a helicopter view over all these papers, and try to get a sense of where we are in AI music creation, and also what's the status of these models, getting these models in the hands of musicians and actually making them practically usable. And we found basically three main things, or main ideas why this is actually challenging. And the first one is that AI is not really easily decomposable. So that means that when you create a song, you maybe want to create one model that just an end-to-end model that creates a song, but this actually doesn't work. And I'll give examples of these 3 points in the next couple of slides. But it turns out you need separate AI for each of the individual parts. Like creating one end-to-end model to generate a song is just really, really hard. Then the next difficult thing that comes up when you create separate parts for each of these song elements, that it's a lot of work to stitch everything back together and make a good song. So instead of the technical knowledge that you need to build these models, when you separate these things out, you actually need a lot of songwriting skills as well to stitch them all back together. And then another problem is that when you have a model, it's not easily steerable. So what if you have a good model, you like the output, but you would like it to be a little bit darker, for example. So you have some melody generative, a model that can generate good melodies, but you want the melodies to sound a little bit darker. it's really hard to go into your model and find the knobs, which knobs to tweak to change your output. And I'll give some examples for each of these points. And at any moment in time, if you have questions, please just interrupt me and ask me a question. So as I said, first challenge is that AI is not easily decomposable. So a lot of the teams started out with creating end-to-end models. They thought we can make a model. We'll just train it on a bunch of historical Eurovision data sets, for example, audio or MIDI. We'll just train it on that, and we'll generate a song, and either we'll let it perform by a band, or it's a generative audio network. It will just generate a song. And all of the teams that tried this failed miserably. They all documented this in their process document, and they all noted that this was super hard, and the output was basically rubbish. So what they ended up with, all of the teams ended up with separate models for each of the elements of their song. So one nice example of this is Databots. They did a collaboration with Portrait XO, and they created the song "I'll Marry You, Punk Come." And what they did is that they started out with exactly this idea. They had a audio generative model. They trained it with a historic data set of Eurovision songs, and the output that they finally got, it kind of sucked. But they used it as inspiration for their new song. So what they did is they listened very carefully to the output of the model, and they heard lyrics in this output, and they heard some melodies, and they took this as inspiration for writing the actual song. And the model that so it generated some lyrics and some singing voice. And what they heard in these lyrics, which were nonsensical, of course, but they heard "I'll marry you, punk come," which was the basis of their what they used as their lyrics, and also the basis of the story of the song that they eventually created. And that sounded like this. So what you hear here is at the beginning this is the output of the generative model. So you hear a voice, and it kind of sounds like "I'll marry you, punk come." And then the singer, Portrait XO, she listened to it and she created her own version of it, her own melody, and she's the second voice that you hear. So she sings on top of it. So I'll play it again so you can hear it again. So although they failed in generating an entire song, they did generate ideas, and they did generate a melody, some text, some lyrics that they used for their eventual song. So this is an overview of kind of like a breakdown of all the elements that the teams used in their songs, and which parts were created by humans and which parts were created by AI, or kind of like a joint collaboration between AI and humans. So you see, vocal synthesis is something that a lot of the teams tried, and they mixed it in most of the times with the human performer, for example, and they used some really interesting and strange approaches. So a lot of the teams used Cincy. I think this is because it's widely available and it's easy to use. You can just use it. You can just install it and try and work with it. But there were also teams who actually just generated speech with the speech tool in their Mac. So they just let their Mac speak, and then they used some kind of a mellotron or some other method, basically to turn it into to give it a melody or give it some kind of pitch, a changing pitch over time, and to match it with their song. And there were some other really interesting just combinations of these kind of tools that really showed that there wasn't it was very, let me say, creative way of generating these voices and these singing voices. As you can see, the most of the teams generated lyrics, and this is also because these models are widely available. So GPT-2 model was at that time readily available, and pre-trained models were everywhere. So what most of the teams did is they took a pre-trained model, they transfer learned it with some Eurovision Song Contest data set, so that we were able to generate some lyrics that were similar to Eurovision lyrics. So yeah, this is of course often used in combination with the vocal synthesis. So like I said, lyrics were often generated, and after that, some kind of vocal synthesis was used to generate these. Does anybody have any specific question on the vocal synthesis? I can give some more examples of what teams used.
Yes, please.
Anything specific?
Would be interesting to know what kind of vocal synthesis they used. What was the basis for it, and yeah. So generally, any examples in terms of how they did the vocals would be interesting.
Yeah. So I have on the next slide, I have an overview of the actual models that were used. So maybe that's also interesting to have a look at. So there were teams who were sorry, who were using a generative model just to generate audio, like WaveNet, Sample RNN. So they trained on for example, they took the Eurovision songs, existing Eurovision songs or historical data set. They used a signal separation to isolate the vocal track, and they trained these models to generate these new singing tracks, to try to generate new melodies and new lyrics. So this was an example of what Databots also sort of tried. I highlighted here the most common ones. So this is so these were used for generating singing voice from isolated vocals. But like I said, Cincy was also often used, and the custom vocal assistants. So these were really creative approaches where they were just generating speech from a website, for example, where there was some just a model where you could type in some words and it will generate some speech, and this was then used to match with the melody. So so really from all the way from generating audio all the way to a compound way of generating these vocals. The second challenge that we found is that the AI is not context aware. So once you have when you try the approach of having an end-to-end model that fails, so you break down the compositional process into all these separate elements where you need a separate element for, separate model for, then it is a lot of work to stitch everything back together, right? So if you have some lyrics and some more lyrics that you generated, how do you fit these together? Or if you generated lyrics, you generate a melody, how do you make sure that these fit together? So one way one team solved this is by by analyzing or trying to find stress patterns in the speech. So they generated lyrics. They were able to isolate or find where the stress patterns in the lyrics should be, and match that with generated melodies, and see which one of the melodies would match the best with the so which melodies fit the best on the stress patterns. And so this is I have an example here of generated the generated vocals, and then eventually how this ended up in the final song. So this is a generated. These are the generated vocals.
So is beautiful the world.
And this is how it was used finally in the song. And what you hear at the end, actually, the peeping sound, that was actually they took recordings of local wildlife and trained some generative models on that. So they were able to generate, I think it was koala sounds. So they had a generative koala synthesizer where they could generate these songs that were in the key of their song, and it creates small melodies for that. I think it was also really fun.
So is beautiful.
Oh. So another challenge is like I said, it's very hard to find which knobs to turn in a model. So if you have a model that works well, but you want to change it a little bit or gets a slightly different output, this is very hard, especially if you have some deep neural network where this is very hard to get into and change it, right? You can of course do some transfer learning, but then you change the whole model. That's probably not what you want. So this is an example of Databots again, and they had a chorus in one of their songs, or in their song, and so it was in the beginning of their song, and they wanted to have another version of this chorus, but they wanted to have it sound to sound darker, and also kind of like have it kind of like a Bach style cadence. So this is an example of the first chorus. And this is, of course, already a product of different models. But if you want to if you have just take this chorus as it is, but you want to change it so that it is darker and more like Bach, this is, of course, very hard if you just want to do it in the models themselves. So you need separate models to change the output of the first model. So you need some kind of you need to do a lot of pipelining as well, where you take the output of one model and take it as input of the next model to actually get what you want. So you hear a little bit more of a Bach-like cadence at the end. So another really interesting insight, I think, from analyzing all these submissions is that we found that a lot of people said that it really opened the musical field for them. So there were a lot of teams that were that either had a couple of musical people in there, or like musicians or composers, but there were also a couple of teams who had no musical knowledge whatsoever in their team. There was, for example, one a team from a company. They were all data scientists, and none of them had really any musical experience, but they just wanted to see if they could use their knowledge or try it out, see if they could make music. And and they did quite well actually. And what we hear, what we heard a couple of times is that if it wasn't for AI, I wouldn't have been able to make music. Like it really opens it up for those people. So I think that's really interesting. In addition to these kind of like issues surrounding generation of music and sound and things that have to do with songwriting in terms of the eventual product, there are also some issues that are interesting, I think, relating to copyright and ethics. So one thing that was really interesting is that that people had a really interesting idea about their ownership of the song that they created. So some of the teams, so here on the left you see an overview of how the teams discussed their perceived ownership of their output. So some teams didn't discuss it. Some teams thought they were the sole owners of their song, but some teams also thought there was some kind of split or joint ownership. And what is meant with this is that the teams had a feeling that the people who, or the teams or the researchers who created the AI or the models or the underlying framework, they had some kind of a stake or some kind of ownership in their in these songs, which is kind of strange, because it's similar or it's comparable to saying that Fender, for example, the guitar maker, is kind of like part owner of rock songs that are created on their guitars, for example. So teams mentioned the developers or the AI systems themselves, even like kind of like turning the AI system into a human, or at least something or someone who is able to own something. And only a minority only said that they were only themselves or the musicians who provided the training data had had ownership of their song. And on copyright, there were some teams discussed these issues surrounding AI and copyright. So training on the data sets with copyrighted material, for example, did they give them credit, or did they discuss it in some kind of way in the process document? So a majority didn't actually discuss it. And what's also interesting is that a majority of the team also didn't do any research on if was the output, for example, if you train on a particular data set, does the output contain material that might be copyrighted, for example? Is it too similar to the input, for example? There were two teams who actually checked for duplicated material, and they tossed out the material that was too similar to the input data. There was one team that discussed this, there were two teams who discussed it a little bit but didn't consider this duplicating of the material. Last one is a funny one. There was only one team who actually, when they generated lyrics, they checked the lyrics whether they wanted to have it inserted, like whether they wanted to avoid certain words, for example, or certain topics. There was only one team who actually did that. So a lot of teams actually just took the output of the models, the lyrics generation models, and just took them as they were. And what's also interesting is that a lot of teams ended up with lyrics about robots wanting to destroy the world for some reason. It was a recurring theme in a lot of the songs. All right, so this is what I wanted to tell you. So we have another AI song contest this year, and we have a lot more registered teams. We actually doubled in size. We have 50 teams registered right now, and we also have a couple of late registrations. And we have a great jury. So we have Imogen Heap, for example, the tech and music artist. We have Uncanny Valley. Those were the winners from last year. And we have professors from universities from all over the world. Yeah, that's what I wanted to say. Do you have any questions?